Welcome to today's class on Is Matter Around Us Pure? In the previous class, we discussed about matter and how matter can be classified on the basis of composition. So we classified matter into pure substances and mixtures. Now under mixtures, we learned about two kinds of mixtures. One is homogeneous and the other is heterogeneous. Now, what do we call homogeneous mixtures? Homogeneous mixtures are called solutions. So you can see one solution here prepared by putting salt. This is salt in water. So this will give you a salt solution. This is called homogeneous because the composition of the solution will remain same every part of the solution, which means the salt we put or sodium chloride we put will get evenly distributed in the solution. Now let us make some observations about the solution. Does light pass through it? That means, is it transparent or not transparent? Transparent means, can light pass through it? Obviously, you can see the solution is transparent. Light can easily pass through it. Can we see the particles inside? We cannot see the particles inside because particles are not visible. They are not visible because the size is extremely small. So what should be the approximate size of the particles? This must be less than 1 nanometer. Size of solute particles is extremely small. Any other observation? Will the particles settle down after some time? Can we see all the sodium chloride settling down at the bottom after some time? That will not happen, as we know. So particles will not settle down. Particles will not settle down. They will not settle down because they are not under the effect of gravitation. Gravitation has got no effect on the particles of the sodium chloride because they are extremely small. Any other observation? Can we separate the particles by filtration? No question, because particles are so very small, so we cannot separate them by filtration. So this also does not happen. Is there any other observation we make? That's all. So we have seen that this is transparent, they're not visible because it is extremely small. The particle size is less than 1 nanometer. It will not settle down, so they are not under the effect of gravitation, and you cannot separate the particles by filtration. Let us see a little more about the mixtures. Now look at these two mixtures. This is rice water. As you can see, this is when the rice is washed in water. So what you get is rice water. Now this can also be obtained if rice is heated in water, boiled in water, and basically this is starch plus water. And we have taken another example. This is milk. Now let us make the observations we made for true solutions. Do you think this mixture is transparent? Transparent means whether light can pass through it or not. As we can easily understand, this cannot be transparent. Neither it is opaque. This will be partially allowing the particles, the light to pass through it. So this is translucent. Translucent means light pass through it but not completely, partially. The second observation we can make, do you think the particles of milk will settle down after some time if you keep it for a long time? You think particles of milk or milk powder be at the bottom of the milk? That does not happen. So the particles do not settle down. Which means in this case also the particles are not under the effect of gravitation. But as you must have guessed, the size of these particles are little higher, little bigger than size of solutions. That is why it is not looking transparent. That is why it is translucent. So size is little higher than that of size of the particles is little higher than that of solutions. This is in the range of 1 to 100 nanometers. Even if it is in the range of 1 to 100 nanometers, they would not settle down. Do you think we can separate out the particles of milk or particles of rice water by filtration? This again is not possible. By filtration, by normal filter paper, we cannot separate the particles of this type of mixtures, and we call such mixtures colloids. And what kind of mixture is this? Do you think this is homogeneous or heterogeneous? Even if this looks like a homogeneous, this is not homogeneous, this is heterogeneous, which means the composition is not same throughout, it can vary. So colloids are heterogeneous mixtures. We cannot separate the particles by filtration. Size of the particles is little bigger than solutions. It is in the range of 1 to 100 nanometers, and they do not settle down, and they are translucent. Now there is one more property which is very interesting about these colloids. Let us discuss it after seeing. All of you must have seen this. So what is happening? This is a dark room, and light enters through the window. You know, the path of this light is visible. Here also you can see in a dark room, light enters and the path is visible. And this is a very, very common observation. This happens because the particles in the air, in this case it is a dark room, here particles in the dark room, the particles here also particles in the dark room, here particles in the air. These particles can scatter the light. So when it scatters light, the path will be visible. And this phenomenon is called Tyndall effect. So Tyndall effect is shown by colloids. Solutions cannot show Tyndall effect because the particle size is not so big. Let us see the rest of the observations. So one major difference between solutions and colloids is the particle size, and this is the most fundamental difference between solutions, we call them true solutions and colloids. So all the other differences in properties is because of this particular difference, the size of the particles. So we have also seen one more property here, Tyndall effect. Let us see the next mixture. This is water, and what we have done is we put some sand in it, and you can see sand, if you stir it, it will mix with water, but it will settle down ultimately. This settles down. So let us make all the observations quickly. Number one, particle size is the fundamental difference here. In this case, particle size is more than 100 nanometers, and that is the reason they settle down. They settle down, which means the particles are under the effect of gravity. And do you think these particles be separated by filtration? Definitely. So we can separate the particles by filtration. We can separate the particles by filtration. I'll explain what filtration is actually about, how it is done. And the particle size we have already seen, they settle down because they are under the gravity. And what kind of mixture is it? Homogeneous or heterogeneous? That's very easy to understand. It is heterogeneous. Heterogeneous because the composition will not be same throughout. Any other observation? Is it transparent or translucent or opaque? Definitely it is opaque. Like if you stir it, the sand particles will mix with the water, and light cannot pass through it, so it will be opaque. So these are the observations we can make about and what we call them suspensions. So we have seen true solutions, which are homogeneous, Under heterogeneous mixtures, either the mixture can be a colloid or it can be a suspension. The fundamental difference between all this is the size, not the nature of the particles, just the size of the particles. This is what a filtration is all about. We will take a conical flask or a beaker, a funnel. This yellow is filter paper, and we put the solution inside. In a true solution, you will not get any residue. True solution, no residue. Colloid also, there will not be any residue, but if it is a suspension, you will get the residue here. So if you can separate the particles by filtration, it is a suspension. Now look at this. This is another example or another experiment. You can see two beakers with one containing a true solution and other containing a colloid. So when light is passed through it, you can see the path of the light is visible inside, and that is called a Tyndall effect, whereas path cannot be visible inside the true solution because it just goes through it, because it is transparent. Here path is visible because it is translucent. Now this experiment in a schematical way, you can see light source, solution, colloid and suspension. Through the solution the path will not be visible. Here you can see the path is visible. Can you see this? And the same thing happens in the case of suspension also. So let us summarize all the differences in properties. True solution, it is homogeneous, and the two components are called solute and solvent. Colloidal solution, it appears to be homogeneous, but it is heterogeneous. Suspension is very easy to understand, it is heterogeneous. True solution is transparent, this is translucent, and this is opaque. Suspension is opaque. Now let us see the particle size. True solutions less than 1 nanometer. Here it is 1 to 100 nanometers, and in the case of suspensions it is more than 100 nanometers. Try to find out the relationship between nanometers and centimeters. Similarly, nanometers and meters on your own. Centimeters and meters. How much nanometer makes 1 centimeter or 1 meter? Now the particles are not visible even with a powerful microscope in the case of true solutions. Particles in the case of colloidal solutions are also not visible to naked eye, but it can be visible with the help of a microscope. And the suspension, they are visible even with the naked eye, as you know. True solution, the entire solution passes through the filter paper as well as semi-permeable membrane, whereas in the case of colloidal solutions, particles can pass through ordinary filter paper but not through a semi-permeable membrane. Whereas in suspension, as you know, particles cannot pass through either a filter paper or a semi-permeable membrane. Find out some examples for semi-permeable membranes. Next difference is true solution. The solute particles do not show Tyndall effect. Colloidal solutions, as you have seen already, they show Tyndall effect. And suspension particles may or may not show Tyndall effect. Again, it depends on the size of the particles. We have written the Tyndall effect. spilling around. Here it's Tyndall effect. Okay. The particles do not settle down due to gravity. The particles of true solution are not under the effect of gravity, whereas in the case of colloidal solutions, they do not settle down because particles are not under the effect of gravity. And suspensions, you can see they are under the effect of gravity, so they do settle down. For example, chalk powder in water or sand in water. So hope you understood the differences in properties between true solutions, colloidal solutions, and suspensions. That's all for today's class. See you in the next class.